Hello all, welcome to Code Hub. Let us solve the today's LeetCode daily challenge. And the problem is numbers with same consecutive differences. Return all non-negative integers of length n such that the absolute difference between every two consecutive digits is k. Note that every number is in the answer must not have leading zeros. Okay, leading zero is not available, not allowed. So for example 01 has one leading zero and is invalid. Okay, you may return the answer in any order. So this is what the problem is. We are given an integer n and a k. If n is equal to 3 and k is equal to 7, so we have to return all the non-negative integers of length 3. So what are the length 3 that is having a length 7, that is having any two consecutive digits with size equal to n. So we have to form the digits with size equal to n. So what is our approach? So such that every two consecutive digits, the absolute difference between every two consecutive digits is k. So what we can do is we can form the digits as well. So we are allowed to have 1 2 3 4 5 6 7 8 9. So all the 9 digits are allowed, and leading zeros are not the leading zeros are not allowed. So what we can do is first if we want to check for each and every numbers, that will be brute force. What is the brute force? If n is 3, then we start from 100 till 99 till 999. We will be checking for each numbers. We will be checking whether the absolute difference is k. So this is what we will be checking. So this will be very time consuming, so the time complexity will be very large if n grows till 9. If n is 9, then what we'll be doing is we will be starting for all the numbers from 1 lakh something. It is ones, tens, hundreds, thousand, 10,000, lakhs, 10 lakhs, crores, even 1 crore till 9999999. For each and every number we will be checking this, whether this is consecutive digits are equal to k. So what we can do is this is nothing but the brute force approach, and this is very time consuming. So what we can do is we can go level wise in the sense we can go use a queue to queue such that we can generate the next possible set of numbers, a next possible set of numbers in the next level, and that level is also valid. That level, we are maintaining those numbers also valid with the absolute difference equal to k. So how we are going to do is we are just going to do a BFS traversal in these set of numbers. If our numbers size is equal to n, then we will break out of this loop and we will be coming out, and we will be inserting every numbers which are inside the queue. So what we can do is first we have inserted 1 to 9 inside our queue. So after inserting 1 to 9, we will be popping first one. With one, what are the elements we can add such that their absolute difference is equal to k, because their two consecutive digits should be equal to k. So what we can do is either we can add 1 plus 7, which is 8. Either we can add 8 to our answer, 8 to 1, or we can add 1 minus 7, which is nothing but it will go to negative number. So we cannot add a negative number, so we can add 1 plus 7, which is 8, so that their absolute difference 8 minus 1, which is 7. So it is this is getting satisfied. Next what we can do is we will be popping out 2. So when we pop out 2, what we are going to add? We will be adding plus 7, which is plus k. Why plus 7 in the sense plus k I am just adding. I am not adding anything else. Plus 7, 2 plus 7, which is 9. So 9 gets added. So then we cannot add 2 minus 7. So it is a negative number. We cannot add that. Then 3 plus 7, which is 3 plus 7. It is 10. 3 plus 7 is greater than 9. So we cannot add this 3. We will just pop it out. Leave it as such. So let us go for 4. 4 also we cannot add. 4 plus 7, which is 11. We cannot add. We can leave it. 5 plus 5 cannot be added. Leave it. 6 cannot be added. 6 cannot be added. 6 plus 7, which is nothing but 6 plus 7, which is nothing but we cannot add it. 7. 7 can be added because why we can add this 7? Because 7 is itself equal to k, so that we can add the next element to be zeros. If the current element is itself equal to k, then we can add just 0 to it. We can append that 0 to it. So we have appended it. So next we can go for 8. For 8 we cannot add 7, it will go greater than 9. For 8 we can subtract 7, so that their consecutive digits is absolute difference is equal to k. So 8 minus 7, it's nothing but 1. So 1 can be added. 9 is also 9 minus 7 is 2. So 2 can be added. So now these are the set of numbers that is in the next level. So now we will process these set of numbers alone, so that we will generate the next set of level. If the next set of level after the processing of this set of levels, we will get a 3-digit numbers. Then after the processing 3-digit number, we will get a 4-digit number. So you can see for each and every levels we are going for 3-digit, 4-digit, and this ultimately represents the number of digits that level should have. So whenever we reach the number of digits equal to n, then we will break out of this loop, and that level will be having our answer. So let us process this second level. So first we will pop up 18. From 18 the last number is 8. So with that 8 we can add plus k or minus k. With 8 plus k it is greater than 9, so we cannot add. So we can try for 8 minus 7. 8 minus 7, which is nothing but 1. So 1 is a positive integer, so we can add 1 to our answer. So next 2 9. For 2 9 we cannot add 7. 2 9 again, 9 plus k we cannot add it. So 2 9 plus minus 7 can be added because it is a positive integer. 9 minus 7 is 2. So 2 can be added. So next 7 7, then 0 7 0 0 plus k, which is 0 plus k is nothing but 7. So 7 can be added, it is a positive integer. 0 minus k cannot be added, it is a negative integer. Next 8 1. 8 1, 1 is the last number, 1 is the last digit. With that last digit, either we can add k or subtract k. While adding it k, we are seeing whether it is a positive integer. Yes, 1 plus 7 is 8, so we can add 8 to our answer. We cannot subtract it. Next let us go for 9 2. 9 2, the last digit is 2. 2 plus 7 is 9. 9 is a positive integer, we can add it. So 9 is added, that's it. So we have got our set of the next set of levels. So next when we see this, the current element size is equal to n, which is equal to n, we can break out of this loop, and finally we have arrived at our answer. So if you didn't understand this approach, let me give an walkthrough for the second example as well. So let us take for second example. Second example is nothing but n is equal to 2 and k is equal to 1. So first we will be having a set of numbers 1 2 3 4 5 6 7 8 9. Since we should not have a leading zeros, we are not adding zeros into our queue. So the queue contains 1 2 3 4 5 6 7 8 9. So we are processing the first level. While processing first level, we will actually end up having 2-digit numbers. While processing second level, we will end up having 3-digit numbers. So so we are just doing n minus 1 level times. We are just processing it. So first we can process it. Let us see. Let us see. Okay, let us process now. One is the front number, front integer. We are taking it. Either we can add k or subtract k. K is 1, so 1 plus 1, which is 2. 2 can be added. So before that, 1 is itself equal to k. So what we can do is, first we can add a 0 and push it into our queue. Next we can try to add 1 plus k. 1 plus k can also be added. So 1 plus k is nothing but 2. 1 plus 1, which is 2. 2 can be added. Let us try to go for the next process. Next process is 2. For the for the second number, 2 when we add k, 2 plus 1, which is 3. 3 can be added. If we subtract k, 2 minus 1, which is 2 minus 1, which is 1. So 2 1 is also a possible answer. So next we can process 3 while subtracting k with from 3. So 3 minus 1, which is 2. 2 can be added. 2 is a positive integer. When we add k, 3 plus 1, which is 4. 4 can be added. Next we can process 4. 4 with, while doing 4, if we subtract 1, which is 3. 3 can be added. 4 plus 1, which is 5. 4 5 can be added. Next for 5, 5 minus 1, which is 4. 4 can be added. For 5, when we add k, 5 plus 1, which is 6. 6 can be added. Next while processing for 6, 6 minus 1, which is 5. 5 can be added. 6 plus 1, which is 7. 7 can be added. While processing for 7, 7 minus 1, which is 6. 6 can be added. For 7, when we add k, 7 plus 1, which is 8. 8 can be added. While processing 8, 8 minus 1, which is 7. 7 can be added. 8 plus 1, which is 9. 9 can be added. Next, while processing 9, carefully listen to it. We are subtracting k. So 9 minus k, which is nothing but 8. 8 is a positive integer. We are adding it. Again we are just adding k to 9. 9 plus k, which is 10. 10 is greater than 9, so we cannot add a 2-digit to it, so we are not adding 9 10. That's it. So finally this level we are having our answer. So we are just doing a DFS traversal in this current set of numbers. So we are here here our constraints is n is greater than 2 only, so we don't want to worry about if my n is equal to 1. So directly what we can do is, first we can push all the numbers from 1 to 9. So q which is having an integer number, and we can have a loop for int I equal to 1, I less than or equal to 9, I plus plus, q dot push off q dot push off I. So now we have pushed the first set of levels. So we will have to run a loop for n minus 1 times. So what we can do is, first we can decrement n. So we can run a for loop, or what we can say is, we can run a loop while n minus minus. So while n is greater than 0, we will be processing it. Inside this loop, we will first take the size, int size equal to q dot size. So we will be processing for this for this level alone. First, for int I equal to 0, I less than size, I plus plus, auto num equal to q dot front. The front element we have got it. We are just popping the q dot front as well. So now what we are doing is, we have got the number. So either we can subtract k or add k. So subtract k, add k. So what we can want to do is, first we want to have the last digit. So to get the last digit, we can do like this. We can have int last digit. Last digit is nothing but num mod 10. So it will give me our reminder. Give me the reminder. Yes, it is correct. So we have the last digit. Now if my last digit minus k is greater than or equal to 0, if my last digit minus k is greater than or equal to 0, then I can add this last digit minus k to our. So we can have in another variable subtract k, last digit minus k, int add k is nothing but last digit plus k. So if my subtract k is greater than or equal to 0, what I can do is I can add this digit, this subtract k to I can append this subtract k to our number. So how we can do it? If we are having a 12 and if I want to add 1 to it, what I can do is 12 star 10, which is nothing but 120. I can add this one so that I will get 1 to 1. So like this I can just append it. So what I can do is num equals to first num star 10, then I can just add subtract k. Similarly, if my add k is also, if my add k is lesser than or equal to 9, then what I can do is similarly I can add num. Oh, this is a local variable. I cannot change the num value. So I can do what I can do is I can have a new num to be int new num. Int new num to be num start 10 plus subtract k. I can push this new num, q dot push of new num to our queue. Similarly, I will add new num star 10 plus add k, q dot push of new num. So if I want to declare this new num as well, in new num. Okay, I have declared it. And finally our answer is inside our queue only. So I will say vector int resultant or numbers with some same consecutive differences. Numbers. While my queue is not empty, what I can do is I can push numbers dot push back of q dot friend, and numbers dot pushback of q dot friend, q dot pop. As simple as that. And finally I'm just returning my numbers itself. So hope this is clear. Let us try to see whether it is accepted or not. Yeah, it is accepted. Let us try to give our example test cases as well. What if my k is 0? If my k is 0, actually the absolute differences cannot be 0, right? The absolute differences, okay, it will run. Even if my k is 0, the differences will be run. Okay, let us try to submit our code. So here the time complexity is much reduced. We are just creating our numbers. So we got a wrong answer. I expected it will be, yeah, it will be for this case, right? Yeah, I expected this. If my k is 0, I can do only once, because we are appending twice. We don't want to append twice, right? So what we can do is, if my k is 0, Only once I can do it. What I am doing is, even for subtract k and add k, I am just doing the same repetitive process. For subtract k once and add k once, I am just doing. So while doing for k is 0, I will have a boolean variable, bool k flag. I will name it as k flag, which is false. If my k is 0, then I will make this k flag to be true. So if my k flag is true, if my k flag is not true, alone I will just do this, or else I won't do this. Only once this will run. This will not run again, so that we will not get a redundant answer. So let us try to see. Yeah, we are getting our answer. This is true. Or else what we can say is, if my k is not 0, k is not equal to 0 alone, I will do this. If my k is 0, why should I redundantly do the same thing what I done for subtract k and add k? So I don't want to do the same process, right? So that's what I'm just doing. So we can eliminate these 3 lines. That is still confusing, right? So now let us try to run our code. So this will be the edge case actually. Yeah, it got accepted. Hope you like this video, and this was a live thought process and we were doing it on live. So hope you like this video. Let us know in the comments. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.